So in the previous lectures we have seen some of the interesting applications of the theory of complex numbers in plane geometry. In this lecture I'll talk about another application of the complex numbers, but in the calculus, especially in evaluating the integrals. Normally we are interested in converting the integrals of the complex functions to the integrals of the real functions. For example, if I have the integral of x squared times e to ix dx from minus infinity to plus infinity, so I can write this integral as x squared times cosine of x dx plus I times integral of x squared sine of x dx from minus infinity to plus infinity. This is an integral of a complex function. This is not a real function. So I've decomposed this integral to a real part and an imaginary part, and we can see here that this function is odd and the limits of the integrals are symmetrical around 0. So this integral is 0 because the integral of odd functions with the limits symmetrical around 0 are 0. And this integral can be written as 2 times integral from 0 to plus infinity x2 times times cosine of x dx. So we have converted the integral of a complex function to another integral of a real function. But in this lecture I'll do the inverse, and this technique is named the complexifying the integrals. So I'll consider an integral as I is equal to integral of e to nx times cosine of mx dx. Normally we use the technique of integration by parts. So I suppose that this function is u, this is d of v. So I know that this integral of u dv is equal to uv minus integral of v du. So I am supposed to do this technique 2 times and finally I can evaluate this integral. So 2 times integration by parts, very complicated equations and very boring. But if I use the technique which is named complexifying the integrals, I can evaluate this integral very simply. I know that e to imx is equal to cosine of mx plus I sine mx. If I multiply 2 sides of this equation by e to nx, e to nx cosine mx plus I e nx sine of mx. And if I integrate the 2 sides of this equation with respect to x, I see that integral of e to n plus I mx dx is equal to integral of e nx cosine mx dx plus I integral e nx sine mx dx. And this is the integral that we are searching for. So we can see from this equation that I is simply the real part of this integral. The real part of integral of e to n plus im x dx. This integral is very simply to be calculated. I can say this is 1 over n plus im e to n plus im times x. So this is e to nx e to imx. This can be written as e to nx times the real part of, if I multiply 1 and n plus mi by the complex conjugate of n plus mi, which is n minus mi, I'll have the real part of n minus im over n2 plus m2, which is simply the norm of n plus im squared, times e to imx. I write it at cosine of mx plus I sine of mx. So the real part of this term can be written simply as n over n2 plus m2 cosine of mx, and the second term is the multiplication of this times I sine of mx, which is simply plus m over n2 plus m2 sine mx. So we have calculated the integral of e to nx cosine mx dx without using 2 times complicated equations, using the method of integrating by parts. Here is the result. In the same way, if I consider this integral e to nx times sine mx, I can say that I prime is the imaginary part of the integral e to n plus im x dx, or the imaginary part of 1 over n plus im e to n plus im x. So this will be e to nx times the imaginary part of n minus im times n2 plus m2 cosine of mx plus I sine of mx is exactly the same as this equation, but this is the real part, this is the imaginary part, and the imaginary part of this term is e to nx times minus im over n2 plus m2 times cosine mx. So minus m over n2 plus m2 times cosine mx. Another term is the multiplication of n over n2 plus m2 times I sine mx. So plus n over n2 plus m2 times sine of mx. And this is the result for I prime, which is defined as the integral of e to nx sine of mx dx. So we have used another interesting technique called complexifying the integrals in order to calculate some integrals of type e to some power of x and x times cosine or sine of a linear combination of x dx. Thanks for your attention.